Hi, welcome to our video on very short answers questions on wave optics. And remember one point here, some questions may be asked for 1 mark, 3 mark or 5 marks or 10 marks. So in that case, you are advised to answer based on the requirement. So state Huygens principle. Every point on wave front is itself the source of spherical wavelet, which is spread out in the forward direction at the speed of light. The sum of these spherical wavelets form a wavefront. Wavefront is there. Each point on the wavefront will act as a secondary source, and the combination of these waves, this will form again wavefront. Next one is, what is interference? So when light waves are superimposed, the modification in the distribution of intensity in the region of superposition is called interference. So interference means whenever two waves are superimposed, their intensity will get modified. That's nothing but the interference. So interference generally we can observe in colors observed on soap bubble, an oil film formed on water. Then what are the conditions for interference? Basically, light should be of same wavelength. That's nothing but monochromatic. Then separation between the source and screen will be large. Then two light sources emit a light waves should be coherent. Then separation between the two light sources will be small. Then write superposition principle. When two or more waves travel simultaneously in a medium, the resultant displacement at any point is due to algebraic sum of the displacements due to individual waves. Say for example, this is amplitude is A and this is A. Now A plus A, it is giving 2A amplitude. It is a constructive interference. When two waves are in out of phase, then the superimposition will be difference of these two. Then next one is the difference between interference and diffraction. Superposition of a two source different wave fronts originating from a two coherent sources, and in diffraction it is due to the superposition of secondary wavelets originating from a different parts of the same wavefront. So here it is a same wavefront, here it is a different wavefronts. Then interference bands are of equal width. When come to the diffraction bands decreases in their width as order increases. All the bright fringes are of same intensity. The bright fringes are of varying intensity. So intensity will vary for diffraction, and for interference it is constant. All the dark fringes have zero intensity. In interference, the intensity of dark fringes not zero. Then so distinguish between Fraunhofer and Fresnel diffraction. For diffraction to occur, the light source and screens are at infinite distance from the obstacle. But diffraction to occur, the light source and screen are at finite distance from the obstacle. To study diffraction, lenses are necessary. So in order to focus the light, we use the lenses. Here lenses are not required. Study of diffraction is easy. Study of the diffraction is complicated. Diffraction can be studied in any direction of propagation of the light. So diffraction can be studied only in the direction of propagation of the light. In this case, the incident wavefronts are plane. So here plane wavefronts, and in this case incident wavefronts are either spherical or cylinder. Then what is the difference between unpolarized and polarized light? So whenever unpolarized light is there, the vibrations of the electric vector will be in all directions. This is unpolarized light. Polarized light we will show like. Then what is a double refraction? This is one of the important question and is the part of our Nichols prism also. So this double refraction has another name that's called birefringence. So whenever light rays passes through a material that has a two different refract indices for wave polarized in different directions, whenever the unpolarized light pass through this calcite crystal, it will split into two parts, extraordinary ray and ordinary. Hi, welcome to the second part of very short answers questions. So the first question will be, what is a black body radiation? So first we have to know what is black body. So black body is a object which can absorb all the electromagnetic radiation incident on it, irrespective of its frequency or angle, or whenever it is emitting, it will emit everything, whatever it absorbs. That is what we call black body. And the radiation emitted by the black body is known as black body radiation. A black body radiation diagram, whatever experimentally observed and theoretically Rayleigh and Wiens try to fit based on a classical mechanics but not able to do so. Then Planck introduced Planck's law, and then he is able to explain. That's what next one is, define Heisenberg uncertainty principle. So Heisenberg uncertainty principle states that it is impossible to measure both position and momentum of a particle simultaneously to any desired degree of accuracy. Whenever we are measuring position and momentum on the same line, we have energy and time. So uncertainties will exist as a default. Next one is, what is the difference between matter waves and electromagnetic waves? Matter wave is associated with a moving particle or material particle, whereas electromagnetic waves are nothing but oscillating charged particles give rise to electromagnetic waves. And wavelength of the matter wave is given by lambda is equal to h by mv. This is de Broglie wavelength equation. Then wavelength of electromagnetic wave is given by lambda is equal to hc by e. Wavelength of matter waves depends upon the mass of the particle and velocity. Here wavelength of electromagnetic wave depends upon the energy of the photon. It can travel with a velocity greater than the velocity of light in vacuum. It can travel with a velocity equal to the speed of the light in vacuum, c equal to 3 into 10 power 8 meter per second. This one, matter wave, is not electromagnetic wave, and in this electromagnetic wave we have electric and magnetic fields. Then define wave function and write its physical significance. By using wave function we can extract all the information related to the system. Wave function is a mathematical function describe the behavior of quantum system. So it will describe the behavior of quantum system. It provides the information about probability of finding the particle in particular position or with particular momentum. The physical significance of wave function is that it allows us to calculate the probabilities of different outcomes in quantum mechanical experiments. Next one, what is the de Broglie hypothesis of matter waves? Matter waves also have dual nature, means they will act as a wave as well as a particle. And the relation for this one is lambda is equal to h by p, where h is a Planck's constant, p is a momentum of matter wave, v is the velocity of the particle. Then what is a dual nature of the light? Light has a dual nature. One is a wave nature, another one is a particle nature. Wave nature will be proved in case of interference, diffraction and polarization, whereas particle nature of the light is proved in photoelectric effect, Compton effect, pair production. So combinedly we can say that light has a dual nature. Based on this only, de Broglie proposed matter also has a dual nature. Then what is a Bloch theorem? So Bloch theorem simply says that whenever electron is moving in a crystal, that wave function can be written as the product of periodic function and plane wave function. Periodic function, this is a plane wave function. Then what is the effective mass? So whenever electron is moving inside the periodic potentials, its mass will change due to the field present there, whether it may be electric field or magnetic field. Then the mass is known as effective mass and calculated by this formula. Third part of very short answers question from semiconductors and semiconducting devices. So the first question is, explain the formation of p-n junction diode. P-n junction diode is formed by bringing together p-type n-type semiconducting materials. When these two n-type p-type materials are brought together, the excess of electrons from n-type material diffuse across the junction into the p-type material, filling some holes. This creates the dip region. So here we can see from here to here, this is the depletion region at the junction where there are no free charges. The resulting structure acts as a rectifier. So this allows the current to flow in only one direction but not the other way. Then what is the difference between direct and indirect band gap semiconductor? When we observe the graph carefully, the diagram E versus K, energy versus propagation constant, in this we have two bands, material valency band and conduction band. Top of the valency band and the lower edge of the conduction band lies on the same K value. That is a direct band gap semiconductor. When come to indirect band gap semiconductors, the K value is different for conduction band and valency band. That's the main difference. And based on this one, the applications will change. These direct band gap materials are compound semiconductors. Compound semiconductors means gallium arsenide, indium phosphide. These are used in the manufacturing of LEDs and other semiconducting devices, whereas for direct band gap semiconductors, they are pure germanium, silicon. These are mostly used for solar cell. The lifetime of charge carriers is very less, lifetime of charge carriers is very more. Next question is applications of a solar cell. What do you mean by solar cell? Solar cell is a semiconducting device which converts light energy into electrical energy, and there is a many type of applications for it, for generating the electricity in residential and commercial buildings and powering the satellites and other spacecrafts. That's the main applications. Then providing the electricity to remote locations where traditional power sources are not available, and for charging the batteries for portable electronic devices. And next one is list out the applications of LED. LED stands for light emitting diode, which will convert electrical energy to light energy, and it has a very wide range of applications. And lighting for homes, office and public spaces present days we are using, and displays for electronic devices such as smartphones, televisions, automotive lighting such as headlights and brake lights. So for lighting purpose mainly we use, and signals and advertising displays also we use the light emitting diode. Light emitting diodes are operated in basically forward bias. Next one is what is a Hall effect. Hall effect is a physical phenomena that describes the production of voltage difference across a conductor or semiconductor material when it is placed in a magnetic field perpendicular to the direction of current flow. So whenever we keep a semiconductor in a magnetic field and electric field which are perpendicular to each other, the other direction voltage will be generated due to the separation of the charge carriers. Those are nothing but the electrons, which gives rise to the voltage. That's what we call Hall voltage, and the phenomena what we call is a Hall effect. Then what is the difference between intrinsic, extrinsic semiconductors? Intrinsic, extrinsic semiconductors, basically intrinsic semiconductor is a pure form, and whenever we dope with trivalent or pentavalent impurities to pure semiconductor, we will get a extrinsic semiconductors. In intrinsic semiconductors, holes and electrons are equal in number, whereas in N-type semiconductors, free electrons are more. In P-type semiconductors, holes are more. Then Fermi level lies in between the valency band and conduction band. So this is the Fermi level. Then Fermi level lies near the valency band in P-type semiconductors and near conduction band in N-type semiconductors. Then ratio of majority and minority carriers is unity, but the ratio will be different for extrinsic semiconductor. Then we will go for the difference between N-type, P-type semiconductors. So in a N-type semiconductor, it is a donor type. P-type semiconductor, it is an acceptor type. In this, if we take pure semiconductor and if we do pentavalent, then we will get an N-type. N-type stands for excess of electrons we have. Whenever we take a pure semiconductors and dope with the trivalent, we will get a P-type semiconductors where holes are majority. Donor level lies close to the bottom of the conduction band, and acceptor level lies close to the top of valency band. And the below images shows the perfect crystal N-type and P-type wherever these AS and B are impurities added to the system, and the double dots, whatever we are saying, electrons. Very short answers question from nanotechnology. What are the nanomaterials? Nanomaterials are the materials with the dimensions in the nanometer range. So typically, if it is between 1 to 100 nanometers, those materials what we call nanomaterial. Then what do you mean by quantum confinement? Confinement of the electrons or holes within a nanoscale structure like quantum dot or nanowaves. So when the dimensions of the structures are smaller in the order of wavelength of the electrons or holes, their motion becomes quantized and discrete energy levels are formed. That's what we call quantum confinement. So quantum confinement means based on the size of the particle or size of the material at a nano level, the energy level will change. That leads to formation of these discrete energy levels, and this is the reason behind the unique electronic and optical properties of the nanomaterials. So as an example, in a quantum confinement, we know that when the size of the nanoparticle changes, its color will change. Then next one is surface to volume ratio of nanomaterials. This is another crucial one. So basically, surface to volume ratio, whenever it increases, automatically it increases the reactivity and surface sensitivity in most of the applications like catalysis and sensing. So when we take a bulk material, its surface area is fixed. So when we make it into small parts, what happens is the hidden surface also exposed to the our surroundings. So the reactivity of the material goes on increasing. Then what is the applications of XRD? XRD stands for X-ray diffraction, and X-ray diffraction technique is based on Bragg's law. We are very much familiar with it. It's nothing but 2D sine theta is equal to n lambda, and in this D is interplanar spacing, theta is the incident angle, n is the order, lambda is the wavelength of the incident rays, typically X-rays. So what are the applications for XRD? XRD can be used to determine the crystal structure, then identifying the unknown materials. Then it is used to characterize size, shape and orientation of the crystals and the strain and defects in the materials. Then what is the distinction between XRD and TEM? XRD is typically used to determining the crystal structure, whereas TEM is useful for studying the atomic structure and defects in the materials. So both techniques provide the valuable information about the structure and properties of the materials at the nanoscale. For bulk materials also we can do for XRD. For TEM means we have to make a sample very thin. Then if we want to go into deeper, what is main difference between XRD and TEM? If it is asked for 1 mark, up to here that's sufficient. Say the same question is asked for 5 marks or 10 marks, you have to explain more. So XRD stands for X-ray diffraction, TEM stands for transmission electron microscopy. So both are analytical techniques used to study the structural properties of the materials at atomic and molecular level. XRD is based on a diffraction, whereas TEM works through transmission and the interaction of the electrons with the materials that will provide the information. Next, come to the sample preparation. XRD requires a powder sample or single crystals. Sample preparation is very simple, but when come requires a thin samples that can transmit electrons. So sample preparation is a huge process in case of the TEM. Then information what we will get, crystal structure, lattice parameters and crystal symmetry. From XRD we will get. TEM will provide information on morphology, crystal structure, defects in the materials. Then when come to the resolution comparatively less for XRD, and TEM it is a atomic level resolution we will. Then limitations is, so it is not so, XRD is not suitable for amorphous or disordered materials. TEM can only study thin samples and is limited by damage caused to the sample by electron beam. In a TEM we will use high energy electron beams. Then what are the any 3 applications of nanomaterials? So there are many applications of nanomaterials as well as nanotechnology. When come to the electronics, nanomaterials are used in the production of electronic devices such as transistor, memory chips and sensors due to their excellent electric and thermal conductivity. And in the medicine also it will be used, such as drug delivery, bioimaging, tissue engineering. So many places we can use in the medicine. Not only there, we can use these nanomaterials and nanotechnology in energy sector for production of solar cells, fuel cells and batteries. So due to their surface, due to high surface area and excellent electrical conductivity. Not only that, we can use these nano based materials in environmental things also. Basically it is used in the treatment of a wastewater and reduce air pollution and environmental remediations, they can be used. Then food and agriculture we can use for packing, food processing and crop protection, fertilizer protection. So many places we can use, not only there, textiles and aerospace. Like that, in every field we can apply these nanomaterials. Final episode from lasers and optical fibers. First question will be, write the differences between spontaneous emission and stimulated emission. Whenever radiation interacts with the matter, we have basically three processes: absorption, spontaneous emission, and stimulated emission. Absorption means whenever the energy comes in the form of photon, the atoms which are at a lower level absorbs the energy and go to higher level. And whenever they go to higher level, they cannot stay longer time there. Their lifetime is very, very less. By emitting the same amount of the energy, it will come to the ground state. That's what we call spontaneous emission. Then stimulated emission means, in case of metastable states, the lifetime at the metastable state is more. So whenever another photon is coming with the same energy, the atom which is at an excited state can absorb this, and by influenced by this one, it will come to the ground state by emitting another photon. These two photons move in the same directions with the same properties. That's what we call stimulated emission. In a case of the lasers, stimulated emission is the main thing. So whenever we are saying laser, light amplification by stimulated emission of radiation. So stimulated emission we are using in the lasers process, which is explained by Albert Einstein. Now we will see what is the difference between spontaneous emission and stimulated emission. So spontaneous emission takes place without any external energy. In stimulated emission, it takes place with the help of any external energy. So whenever external energy comes, then only it will come to the ground state. So stimulated emission requires external energy. It is an incoherent radiation. So randomly it will come to the ground state and it will emit different types of the photons having different nature. Whereas this is a coherent radiation, it will come same phase and same wavelength, all properties almost same. It is a low intense and less directional. So in the spontaneous emission, it is emitting in a different direction, so intensity will be low and less directional. When come to stimulated emission, it's a high intense and more directional. That's why we use this one in lasers. It is a polychromatic radiation. Then it is postulated by Bohr. It is postulated by Einstein. Next one, what is a population inversion? So in order to get the stimulated emission, a population inversion is required. What is a population inversion? Normally at a ground state, different energy levels are there. We have 1, 2, 3 like that. Ground state has a more atoms, then higher level, then higher. This is a normal distribution. But population inversion means comparison to ground state, higher energy level has a more atoms. This is a population inversion. So in order to get the population inversion, we have to supply the external energy to pump more number of the atoms to the excited state. Then what are the basic characters of the lasers? Lasers has a many features which are very, very advantageous. One is highly monochromatic, means single wavelength, highly directional, highly coherent, and high intense. Then what are the main components of the lasers? So the essential components of the laser is the active medium. So this active medium may be solid, liquid, or gas. Based on that, we can classify the type of the lasers as well. And the next one is a pumping agent. So in order to pump the atoms from ground state to excited state, we require a pumping. So here we will use electrical pumping, then optical pumping, thermal pumping, like the different methods are there. Then optical resonance. So this optical cavity, whatever we are saying, that's what we call optical resonators. So whenever we take an active medium, there will be two reflecting surfaces. That mirrors may be separately kept, or maybe if this is the solid, two sides will be polished. One side is partially reflecting, another side is 100% reflect. So whenever we pump the atoms to higher energy levels, they will come to ground state in the stimulated emission process and release the laser. So that laser will get enhanced in between these two reflecting mirrors. Once it achieved the required conditions, the laser beam will come out partially reflecting mirror side. Next one is what are the applications of the laser. So sometimes they will ask for 1 mark, sometimes they will ask for even 5 marks or 10 marks also. So if they are asking for 1 mark, just write 3 or 4 applications simply in 3 or 4 points. But if they are asking for long question, we have to write most of the things. Then when come to the laser applications, it is used in telecommunications. So for high speed data transmission in telecommunication systems, we use this lasers, especially in optical fibers also we will use. Then manufacturing, lasers are used in industrial manufacturing process such as cutting, welding and marking the materials including metals. So we can use the lasers in a defense. We can use the lasers in defense and security purpose, including target designation, range finding and missile defense systems we can use. And then environmental sensing in order to identify the weather pattern, pollution, all things we can use the lasers. Then in the scientific instrumentation for the research purpose and even entertainment also we use the lasers as like a laser shows. Then holography. Next one is explain the principle of optical fiber. So basically optical fiber will work on total internal reflection. So this total internal reflections takes place whenever the light rays travel from denser medium to rarer medium. So whenever light is traveling from denser to rarer medium, it will get a deviate. If we increase the incident angle at a particular angle, say for example theta c, ray grazes the interface of the two mediums. If we increase the critical angle, that ray traces back into the denser medium. That's what we call total internal reflection. Next one, what are the applications of optical fibers? So optical fibers are very much used in a communication systems for data transfer, then in the medical, especially endoscopy, laser surgeries and optical coherence tomography, and for sensing purpose we will use in industries, then defense, security, research, energy, entertainment, for all purpose. Mostly these optical fibers and laser has a common applications. And what is the significance of numerical aperture? Acceptance angle and a numerical aperture are the key parameters, whereas this acceptance angle tells what is the maximum angle we can go in order to transmit the signal into the optical fiber, and whereas this numerical aperture determines its light gathering capability. So if we know the numerical aperture of the optical fiber, that can be used in selection of the optical fibers for the transmissions based on the properties like bandwidth, resolution, coupling efficiency, compatibility with other optical fibers. So it is an important parameter in the designing of the optical fibers. And all the best. This is the final episode. Thank you. Like, share and subscribe. See you. Jai Hind.